It's very important for the immune response to have a certain amount of tolerance. Our immune cells need to tolerate the other cells of our body. They need to not become active against them. And a lot of this tolerance is sort of trained into the immune system very early on in life. So soon after birth, immediately after birth, it's still the mom's antibodies in large part are providing immune protection for the baby. But very shortly after birth, the baby's own immune system really starts to build up and start learning these things. So the key, again, with having a healthy immune system is for the immune system to be able to tell the difference between self-antigens and foreign antigens. So this immunological tolerance, this is something that needs to persist throughout life, being able to tolerate our own self cells. That's something that's extremely important. In some cases, in some diseases, that's the very thing that's not happening anymore. So in some cases, our immune cells start to attack our other body cells, and so we would say that they're auto-reactive. They're reacting with our own cells. So that's not a good thing. There are a few different reasons why this can happen. It can just be due to mutations that happen when lymphocytes are dividing. They do have a fairly high rate, relatively high rate of mutation. So occasionally it will just happen to mutate in the wrong way. Ordinarily, this type of mutation is not a bad thing, because ordinarily this is just providing diversity in the types of antibodies we can produce. But it is possible for the mutation to be just the wrong kind. In any case, however it develops, this can end up leading to autoimmune diseases. And there are a few examples of that here. Some of these we've already seen in passing as we've been surveying other organ systems. Graves' disease, we mentioned this one a while back in the course. And what happens with Graves' disease is that the MHC, the major histocompatibility complex, type 2, class 2, what happens is it actually presents self-antigens instead of foreign antigens. So it presents self-antigens on the cell surface and it shows them to the helper T cells. And then those helper T cells trigger the B cells and cytotoxic T cells to do their jobs, but it's being targeted against our own antigens. So that's Graves' disease. Another good example is rheumatoid arthritis. What happens in rheumatoid arthritis is that our bodies start producing, our B cells start producing antibodies that are aimed at other antibodies. So an antibody targeting another antibody, that would be a problem. That leads to inflammation. One more example, sometimes there might be an organ that sort of ordinarily hides cells away, keeps them locked away, and ordinarily the immune system does not see those cells, so it hasn't learned to tolerate them. And so what happens if those cells are then exposed somehow is that the immune system might think they are foreign. So the immune system gets a little confused, and that's what happens in Hashimoto's thyroiditis, inflammation of the thyroid gland. If this does happen, where the lymphocytes start attacking self cells, there are a couple of mechanisms built in to stop them, which is a good thing. So a couple of different ways that they can be stopped. These ways don't always work. Sometimes it's not possible to retrain the immune system. So that's when these autoimmune diseases become a problem. Speaking of tolerance, so let's talk about allergies. Allergies essentially are just ramped up immune responses to antigens that should not be a problem. So the immune system sees these antigens and it thinks, oh, that's a problem, I've got to deal with it, when in reality it probably wasn't a big deal to begin with. So these types of antigens, we like to refer to them as allergens. Okay, so people who have allergies, essentially they have hypersensitivities to certain substances, and there are a couple of different types of allergies or hypersensitivities that can take place. The immediate hypersensitivities, these are the types that can be caused by foods that people might be allergic to, or by bee stings, or by pollen in the case of seasonal allergies. So this immediate hypersensitivity, it's called immediate because it happens very quickly. Symptoms develop within minutes, seconds in some cases, seconds to minutes, immediately after exposure. And the thing that's really mediating this type of allergy to happen is the activity of B cells. It's an abnormal B cell response. So what's happening is the dendritic cells phagocytose the allergen, and they stimulate the helper T cells. Those in turn stimulate the B cells to produce antibodies. And what those antibodies do is cause mast cells to secrete histamine, right? And we know about histamine. It causes inflammation, causes a lot of those allergy symptoms that we have, that some of us may have. So let's take a look at a picture here, just to recap that. So allergen binds to an antibody on a B cell. That triggers this cell to proliferate, become a plasma cell, produces lots and lots of antibodies. This causes the mast cell to up its production of histamine when it binds to that same allergen. So this is like the first exposure, and then down here, this is like the second exposure to the same allergen. Second time around, the mast cell is going to produce a bunch of histamine, and that's going to lead to allergy symptoms. The other type of hypersensitivity is a delayed hypersensitivity. This one usually takes a few days to develop, 1 to 3 days generally. And this type of hypersensitivity is due to the activity of T cells rather than B cells. So abnormal T cell response. This ends up, in the end, leads to secretion of lymphokines other than histamine. So it's a different type of immune response, but the end result is still some type of allergy develops. So the treatment in this case, instead of just an antihistamine, the treatment would need to be something else because it's not histamine that's being produced here. So usually it's corticosteroids to treat this type of hypersensitivity. Examples of this would include after exposure to poison oak or poison ivy or poison sumac. All of those are plants that can trigger a really unpleasant immune response, and it's a delayed, so this is an example of delayed hypersensitivity. Okay, last note for this chapter is let's revisit, this ties in with the CD8 T cells, and I want to just end with talking about tumor immunology a little bit more. So what is a tumor? A tumor is an abnormal growth. It's an abnormal mass of cells, and it starts off from just one single cell, a cell that starts to divide more than it should. And in most cases, this is a result of altered gene expression in that one original cell. Altered gene expression, what would cause that? Well, it can be caused by mutations. Mutations, occasionally they happen spontaneously, just during normal cell division, but they can also be induced. And many cancers are caused by induced mutations. And what is it that's inducing the mutation? It can be exposure to carcinogen, different chemicals. It could be too much sunlight. So there's some sort of a triggering event that causes DNA to mutate. They can also be induced by some viruses. So some viruses, depending on their mechanism, they can alter gene expression in the host cell. A great example of this is human papillomavirus. Human papillomavirus, what this virus does is it promotes cell division, kind of like intentionally. And so every time the infected cell divides, the virus is being replicated right there along with it. So these viruses promote cell division. This leads to formation of warts, human papillomavirus, so genital warts. There are other types of papillomaviruses too. All of them lead to production of a small tumor. And in a lot of cases, regardless of which of these mechanisms initiated tumor development, regardless, a lot of times these tumors can be recognized by cytotoxic T cells. So a lot of times, tumors, just due to the fact that they produce certain things and stick them up on the cell surface, they sort of flag themselves for destruction. A lot of times, cytotoxic T cells can recognize them just sort of automatically. But there are some tumors that secrete substances to suppress immunity. And those are the ones that become a problem. Those are the tumors that can evade immune surveillance and end up becoming cancerous. So cancers arise ultimately when the immune systems are not able to do their job. They fail to stop the growth and the spread of the tumors. Since this happens occasionally, this is why it's so important to go through cancer screenings that are appropriate for your age and your family history. Screening for cancers, early detection is extremely helpful for having successful outcomes. And a number of cancers also can be prevented with lifestyle choices. So this diet and exercise are very important. Some of these inhibit cancers because they help to ramp up the immune response. Eating a high fiber, low fat diet, and then exercising that minimum like 20 minutes per day or 30 minutes 5 days a week. Goal is to get 150 minutes per week of moderate intensity exercise. And that combined with cancer screenings is a good plan.